Good morning, students. Let us discuss the new chapter, hyperbola. So the hyperbola is a conic whose eccentricity is greater than 1 is what we have discussed before in the chapter ellipse. If the eccentricity E is less than 1, then the conic is ellipse, and if E is greater than 1, then it is said to be a hyperbola. Hyperbola is defined to be the locus of a point which moves in a plane so that its distance from a fixed point to its distance from a fixed line is greater than 1. So the equation of the hyperbola in its standard form is x square by a square minus y square by b square is equals to 1. Remember, x square by a square plus y square by b square is equals to 1. In the place of minus it is plus, then it is a ellipse. But here this is hyperbola. Let S be the focus. What is focus? It's a fixed point. L equals to 0 be the directrix, and C be the center of the ellipse, center of the hyperbola. Let C be the center of the hyperbola, and this is the x-axis and this is y-axis. This is our L equals to 0. So fixed line which is the directrix, and this is L dash equals to 0. So S be the fixed point. Let P x1 y1 be any point on the hyperbola. So this P is x1 y1 be a point on the hyperbola. So from this I will draw a perpendicular on the x-axis. This is N and this is M. So M comma N are the projections of M comma N are the projections of P on M is the projection of P on the directrix, and N is the projection of the same P on the x-axis respectively. So Z is the projection of S on the directrix. Z is the projection of P on the directrix. Since the eccentricity E, what is the eccentricity? So the locus of a point which moves in a plane so that P's distance from a fixed point to that of P's distance from a fixed line is equals to E, and this E is greater than 1. Since E is greater than 1, let A comma A dash divides this SZ in the ratio, divides SZ in the ratio E is to 1. So A divides SZ internally and A dash divides SZ externally in the ratio E is to 1. SZ in the ratio E is to 1 internally and externally. So let CA is equals to CA dash is equals to A. Then this A is A comma 0 and this A dash is minus A comma 0. So since A lies on the conic, A comma A dash lies on the conic means hyperbola. A comma A dash lies on the hyperbola. Can we use the definition now? Its distance from a fixed point SA, its distance from a fixed line AZ is equals to E. From this, SA is equals to EAZ. Likewise, A dash is also a point on this hyperbola. So its distance from a fixed point SA dash by its distance from a fixed line A dash Z is equals to E. So SA dash equals to E A dash Z. So like what we have done in ellipse, the same procedure we are going to do here also. So here I will be finding the distance between the center to the focus and center to the directrix, CS and CZ. The intention behind doing all these things is to find out the distance between the center to the focus and center to the directrix, CS and CZ. Now 1 plus 2 gives rise to SA plus SA dash is equals to E into AZ plus A dash Z. So now everything I will take from the center of the ellipse. So SA is equals to, SA is total CS minus CA. SA can be written as subtracting CA from this CS. So this is CS minus CA plus SA dash. SA dash is CS plus CA dash. SA dash is this. This distance is equals to CS plus CA dash. CS plus CA dash is equals to E into AZ is again subtracting CZ from the CA. So CA minus CZ plus A dash Z. A dash Z is CA dash plus CZ. CA dash plus CZ. So here plus CZ minus CZ gets cancelled. So CA is equals to A and CA dash is also A. So CA is minus A, CA dash is plus A. So these two gets cancelled. CS plus CS is 2CS is equals to E into CA is A, CA dash is A. A plus A, 2A So 2 gets cancelled. Therefore, CS is equals to A into E. So CS is equals to how much now? This distance is AE. So this is AE comma 0 and this is minus AE comma 0. Now SA dash minus SA is equals to SA dash is E A dash Z. SA dash is equals to E A dash Z. That's what we have got before. SA is E A Z. So take E in common. So this is AZ. So the reason for subtracting SA from SA dash is, according to the diagram, SA dash is this much and SA is this. So generally longer minus shorter is what we are doing. So for which SA dash minus SA I have taken. What is SA dash again? SA dash is CS plus CA dash. This is CS plus CA dash minus SA is so total CS minus CA, cutting CA from CS. CS minus CA is equals to E into A dash Z. A dash Z is this. So CZ plus CA dash. CA dash plus CZ minus of AZ is equals to, AZ can be written as CA minus CZ. CA minus CZ. So this is equals to CS, CA dash is A, minus CS, minus into minus is plus, CA is A, because CA is equals to CA dash is equals to A, which we have taken before. This is equals to E into CA dash is A plus CZ minus CA is A, minus into minus is plus CZ. So this minus A, this plus A gets cancelled. Here CS gets cancelled. So A plus A, 2A is equals to E into CZ plus CZ is 2CZ. So 2 gets cancelled. So therefore A by E is equals to CZ. So the distance between the center to the directrix is, this is A by E. So this is A by E comma 0 and this is minus A by E comma 0. So this distance is also A by E. So earlier we got CS is equals to AE, distance between the center of the hyperbola to the focus. So CS equals to AE. Let P x1 y1, let P x1 y1 be any point on the locus of the hyperbola. Be any point on the locus of the hyperbola. So now from P I draw a perpendicular onto x-axis and from P I draw a perpendicular on the directrix L equals to 0. So this I call it as M and this is N. Otherwise this is M and this is N. So like A and A dash lie on the hyperbola, therefore we have used the definition. In the same way, P is also a point on the hyperbola. Can we apply the definition for this P as well? So since P lies on the hyperbola, according to the definition, its distance from a fixed point SP by its distance from a fixed line PM is equals to E. From this, SP is equals to EPM. So now, what is PM here? PM equals to NZ, because this is the, what is Z? Z is the projection or normal or perpendicular of S on the directrix. So this is 90, this is 90, this is 90, obviously this is 90. So therefore this is the rectangle so formed. Now this PM equals to NZ can we take? PM equals to NZ. So this NZ can again be written as total Cn minus Cz is NZ. NZ is equals to total Cn minus Cz. Cn minus Cz. And what is Cn here? Since this is x1, y1, since C is the center of the ellipse, which is origin 0, 0. So Cn is equals to x1 and this Pn equals to y1. Px1, y1. So from the center to this is Cn is x1 and Pn is y1. So Cn is x1 minus Cz. We got Cz as A by E. So this is what we get. And so from this, SP is equals to EPM. SP equals to EPM, squaring on both sides. SP square equals to E square PM square. So E square into PM is nothing but x1 minus A by E whole square. And what is SP? S is AE, A by E minus 0. S is CS is equals to AE. Therefore, this is AE comma 0. Okay. So, what is SP? S is AE comma 0. P is x1, y1. Distance formula. Distance between the 2 points. So, this is SP is x1 minus AE whole square plus y1 minus 0 whole square under root. SP square is square root gets cancelled. So x1 minus AE whole square plus y1 minus 0 whole square is y1 square. So this is equals to A minus B whole square, A square plus B square minus 2AB 2 x1 AE plus y1 square is equals to E square into this is x1 square plus A square by E square. This is A square by E square minus 2A by E x1. So this is what we have obtained. Now this is equals to x1 square plus A square E square minus 2AE x1 plus y1 square is equals to E square into x1 square, E square x1 square plus E square into A square by E square. E square gets cancelled. A square minus. So E square by E. So E times into 2A x1. So 2AE x1. So minus 2AE x1 minus 2A x1 gets cancelled. A square E square plus A square if you transpose onto this side minus A square plus is equals to this is E square x1 square, E square x1 square, this plus x1 square if you transpose onto this side minus x1 square, this plus y1 square if you transpose onto another side minus y1 square. So this is equals to, take A square in common here, then we'll get E square minus 1 is equals to, take x1 square common here, e square minus 1 minus y1 square. So dividing by a square into e square minus 1 on both the sides, then a square into e square minus 1 by a square into e square minus 1 is equals to x1 square into e square minus 1 plus minus y1 square by a square into e square minus 1. So 1 is equals to a minus b by c, a by c minus b by c. So this is x1 square into e square minus 1 by a square into e square minus 1 minus y1 square by a square into e square minus 1. So this 2 gets cancelled. This implies x1 square by a square minus y1 square by b square equals to 1, where b square is equals to a square into e square minus 1. Remember, this b square equals to a square into 1 minus e square is what we got earlier in ellipse, but here e square minus 1 we get. This point is the path of one point in the plane. So all such points, equation if you want, then the locus of px1 y1 is x square by a square minus y square by b square equals to 1. This is the equation of the hyperbola. Now, what are the points that we have noticed here is, the equation of this hyperbola is x square by a square minus y square by b square equals to 1. Its center C is equals to 0, 0. So therefore, the hyperbola is said to be in its standard form if and only if the center is at the origin. So vertices a comma a dash. So vertices. So what is the definition of a vertex? The point of intersection of the conic, which is the hyperbola here, and the x-axis and the principal axis is said to be the vertex. So a dash are the vertices. So these are plus or minus a comma 0. Plus a comma 0 is a, and minus a comma 0 is a dash. Now for C, S is the focus and S dash is the second focus. So minus a e comma 0. So for C or for chi, S comma S dash is equals to plus or minus a by e comma 0. So equation of the directrices. Equation of the directrices. So this fixed line is the equation of the fixed point S here. So this fixed line is said to be directrix of this fixed point, which is the focus. So this directrix is this line is the directrix of this focus, and this line is the directrix of this focus. So and these two lines are parallel to y-axis. Any line which is parallel to y-axis is of the form x equals to k. So these are equals to x equals to, this line is, this is a by e, that means x equals to, this is a by e, and here x equals to minus a by e. So x equals to plus or minus a by e. So, and if you take this to be b dash, then a dash is said to be the transverse axis and b dash is said to be the conjugate axis. In ellipse, this a dash is said to be the major axis and this b dash is said to be the minor axis. But here in hyperbola, a dash is equals to how much? So CA is equals to A, CA dash is equals to A plus A, 2A. 2A is the major axis, so that is the transverse axis. So transverse axis. So transverse axis is along the x-axis, that is y is equals to 0 and b dash is equals to 2b. So this is 0 comma b and this is 0 comma minus b. So that is, this is b, this is b. So b plus b, 2b. So b dash is called the conjugate axis. So eccentricity. So this is the connected by the relation we have just seen. B square is equals to a square into e square minus 1. From this, e is equals to square root of a square plus b square by a square. So earlier in the ellipse, this e is equals to a square minus b square by a square. Bigger square minus smaller square by bigger square earlier. That is minus in ellipse. Hyperbola, a square plus b square by a square. So now the equation x square by a square plus y square by b square equals to 1 is transformed to x square, so this is minus, so x square by a square minus y square by b square is equals to minus 1 by rotation of axis. So rotation of axis in the sense, so origin is fixed and without shifting the origin to some other place, actually we will rotate. Then the transverse axis becomes the conjugate axis and conjugate axis becomes the transverse axis. Such type of hyperbola is said to be the conjugate hyperbola, which we will be seeing now. The equation x square by a square minus y square by b square equals to 1, which is the standard form of the hyperbola which we have derived, of a hyperbola is transformed to x square by a square minus y square by b square equals to minus 1 by rotation of axis. So this is the axis, coordinate axis. So keeping the origin fixed, so again it rotates like this 90 degrees. Then the center is fixed, which is the origin, and this is a dash. Earlier also the same a dash is that. So now this is b dash. Now, so now this is the transverse axis and this is the conjugate axis. Earlier the transverse axis is x-axis. Now the transverse axis is y-axis, along y-axis. So then x square by a square minus y square by b square equals to minus 1. So if you take minus as a common, then y square by b square minus a square by a square is equals to 1. This hyperbola is said to be the conjugate hyperbola. So here the center is C, 0, 0 and vertices vertices B comma B dash. So B comma B dash. This is A comma 0. This is minus A comma 0. This is 0 comma B. This is 0 comma minus B. So vertices are 0 comma plus or minus B. The foci S dash is equals to 0 comma plus or minus BE. So this is S and this is S dash. This is S and this is S dash. This is 0 comma minus BE. This is 0 comma BE. Now the equation of the directrices. Equation of the directrices. So these are the equation of the directrices. So this line is the directrix of this focus. Fixed point, this is the fixed line. So this S dash is the fixed point. Its corresponding directrix is this. So this is y is equals to. So this y is equals to, this is how much? Plus b by e. This is minus b by e. This line is parallel to x-axis. Any line which is parallel to x-axis is the form y equals to k. So y is equals to, this is 0 comma minus b by e plus b by e. This is 0 comma minus b by e. So this is equals to, y is equals to b by e. Y is equals to minus b by e. So this is equals to, y is equals to plus or minus b by e. And the eccentricity E is equals to, this is connected by the relation. Earlier B square is equals to A square into E square minus 1 we got for the hyperbola. So for the conjugate hyperbola, A square is equals to B square into E square minus 1. Therefore E is equals to, here B square minus A square by B square. Earlier it is A square minus B square by A square. So this is the conjugate hyperbola. Now, what if the length of the transverse axis is equals to length of the conjugate axis? Let us see that. So, if the length of the transverse axis is equals to length of the conjugate axis. So for the parabola, for the hyperbola, x square by a square minus y square by b square equals to 1. The transverse axis is 2a. That is, for this 2a, the length of the conjugate axis is 2b. So, length of the transverse axis is equals to length of the transverse conjugate axis. 2a is equals to 2b. In other words, a is equals to b. If the length of transverse axis is equals to length of the conjugate axis, that is a is equals to b, that kind of parabola, that kind of hyperbola is said to be a rectangular hyperbola. Rectangular hyperbola. So, its eccentricity is E is equals to root 2, because b square is equals to a square into e square minus 1. For the hyperbola, x square by a square minus y square by b square equals to 1. So b square equals to a square into e square minus 1. The relation among a, b and e is this. So if A is equals to B, then this B square also becomes A. So A square is equals to A square into E square minus 1. So this is A square E square minus A square is equals to A square. So this is 2A square is equals to A square E square. A square gets cancelled. E square equals to 2. E is equals to root 2. Therefore, the eccentricity of the rectangular hyperbola is root 2. The difference of focal distances of any point on the hyperbola is constant. So, let us take, this is the coordinate axis. This is the hyperbola. S dash be the foci, C be the center, A dash be the vertices, Z dash be the foot of the directrices, L equals to 0, L dash equals to 0 are the directrices. Let P x1 y1 be any point on the hyperbola. So let S dash be the foci, C be the center, L comma L dash be the directrices, A dash be the vertices, E be the eccentricity. So let P x1 y1 or P x comma y be any point on the hyperbola. So x comma y only I take. So I need not generalize the final equation xy with x1 y1. So let n be the projection of P. Let n be the projection of P on x-axis. So M and M dash, M comma M dash be the projection of the same point P on the directrix L equals to 0 and L dash equals to 0. And M comma M dash be the projections of P on the directrices L comma L dash respectively. So since P is a point on the hyperbola, since P is a point on the hyperbola, अरे बाबू हल्का, since P is a point on the hyperbola, its distance from a fixed point, so SP by PM is equals to E. Likewise, its distance from the second focus S dash P by PM dash is equals to E. P's distance from this focus to the corresponding directrix of this focus, that is SP by PM. So now P's ratio of the distances from the second focus to the second directrix. So P's distance from this S dash P by P M dash, because S dash is the focus, its corresponding directrix is this. So now SP is equals to EPM, and here S dash P is equals to EPM dash. Now S dash P minus SP is equals to EPM dash minus PM. So E into PM dash is nothing but PM dash is equals to NZ. PM dash is NZ minus PM dash. PM dash is equals to NZ dash. NZ dash. PM is equals to NZ. So E into NZ dash. NZ dash is CZ dash plus CN. CZ dash plus CN minus of NZ is CN minus CZ. CN minus CZ. So this is equals to E into CZ dash plus Cn minus Cn minus of minus is plus Cz. So Cn gets cancelled. So E into Cz dash, the distance between center of the hyperbola to this directrix we have seen earlier. So this is A by E and this is also A by E. This is A by E comma 0. This is minus A by E comma 0, which we have seen before. So this is CZ dash plus CZ. CZ dash is A by E. This is also A by E. So 2A by E. So E gets cancelled. Therefore we get S dash P minus SP is equals to 2A. But in ellipse we have seen S dash P plus SP is equals to, so sum of the focal distances is equals to 2A we got earlier, but here S dash P minus SP is equals to 2A. The sum of the difference of the focal distances of any point on the hyperbola is constant.